Mitchell. Hello, my name is Mitchell. I'm a second-year master student in the Institute of Laser and Plasma Technologies of National Research Nuclear University, MEPHI. Currently, I work in the Laboratory of Informational Optics and Holography. Our group researches methods and principles of information processing using optical waves. I work on applying machine learning methods for the purposes of digital holography and diffractive optics. Today, I'll talk about neural networks and how we use them in our research.
Neural networks are a subset of machine learning that uses algorithms inspired by biological structures such as human brain. Neural networks train finding hidden patterns in datasets so that they can generalize the output for the similar sets of data. When building a neural network, there is no need to directly program the data processing algorithm. After designing the network architecture, we only need to prepare a well-structured dataset that is best suited for our problem. Training also proceeds without direct human input. Neural networks have a variety of potential applications such as speech and text processing, computer vision, and pattern recognition, various prediction models, and other uses. In our laboratory, we look into potential uses of machine learning in optics and holography. Holography is a method for registering both phase and amplitude of an optical wave by creating an interference pattern with a coherent object wave. Resulting hologram can be used to fully reconstruct the original object wave. We research and develop machine learning methods for high-speed reconstruction of quality 3D scenes from holograms. For example, a neural network can be used for computer hologram generation. In this model, we use images as inputs and holograms generated with forward optical propagations as outputs for our network. This method can effectively generate phase or amplitude holograms and other diffractive optical elements such as kinoforms. The reverse problem for that would be reconstruction of images from holograms. Normally, when reconstructing an inline hologram, the resulting image is covered by parasitic diffractive orders, and additional processing is required for this quality image. A neural network can directly extract the object information from holograms and produce high-quality images without requiring complex and computationally intensive filtration algorithms. Optical encryption is the highest-speed method of data protection. It is achieved by convolution of an image and an encryption key. Object information from the resulting encrypted image is highly recoverable without the key. We explore the possibility of using neural networks to break optical encryption. The model was trained to recover keys from encrypted images. A key extracted by the model can be used to recover the original image. In conclusion, I would like to better define possible fields in optics that can be explored with machine learning. These are fields like microscopy, imaging, digital and computer holography, optical encryption, pattern recognition, and other fields.